Hello, my dear children. Today we are going to discuss the sums in exercise 2.5 in the chapter polynomials. See page number 48. Page number 48. Question number 2. Question number 2 or Roman number 2. In this Roman number, there are three parts. There are three questions are given. Here I am explaining the first question. I am explaining the first question. See here, evaluate 103 into 107. Evaluate 103 into 107 without multiplying directly. Here we should not multiply these two numbers directly. It is easy to find the product of these two numbers by multiplying directly. You have done it in the earlier classes, but you have learnt algebraic identities. So we use that knowledge to find the product of these two numbers. Okay, my dear children, by suitable identity, by using the suitable identity, we find the product of these two numbers because it is mentioned directly, clearly mentioned that we should not multiply these two numbers directly. Okay, my dear children, right. 103 into 107. 103 into 107. These two numbers are very near to 100. Isn't it, my dear children? Right. So 103 can be written as 100 plus 3. Understood, my dear children? We wrote the first number as 100 plus 3 into, and the second number is 107. This number can be written as 100 plus 7. I wrote the second number as 100 plus 7. So, if you observe this expression, it is in the form of x plus a into x plus b. Immediately you have to recollect the suitable identity. For this question, this identity is suitable. This is an appropriate identity. So x plus a into x plus b is equal to x square plus a plus b of x plus ab. This identity is suitable for this question. Like this, we have to identify a suitable identity to solve the given question. Understood this point, my dear children? Right. So here x means 100, a means 3, and b means 7. Okay, my dear children, by comparing this expression with this expression, we get here x is equal to 100, a is equal to 3, and b is equal to 7. So in this identity, we substitute these three values, x, a, and b values. What is the first term? X square. What is x here? 100. So 100 whole square plus a plus b. What is a here? 3 plus what is b here? 7. So 3 plus 7 into x is 100. Understood the second term, my dear children? Right. Come to the third term, AB. What is A here? 3. And what is B here? 7. So 3 into 7. Understood the third term, my dear children? Right. Now we simplify each and every term separately in the rough work. 100 square. Its value is 10,000. Okay, my dear children. Plus, what will you get in these brackets? 3 plus 7, 10. So 10 into 100 plus third term, 3 sevens are 21. Understood these three terms, my dear children? Right. 10,000 plus 10 into 100. Second term is 10 into 100. What will you get here? 1000 plus third term is 21. I wrote the third term as it is. Now we add these three terms. We have simplified each and every term separately. After that, we have to add the three terms 10,000, 1,000, 21. By adding these three terms, what will you get? 11,021. So this is the procedure to find the product of these two numbers without direct multiplication. Understood, my dear children? In examination also you follow these steps to find the product of two numbers by using suitable identity, not by direct multiplication. Understood, my dear children? Right. Now come to the question number 3. Roman number 3. In this Roman also three questions are given. Three parts are there. Here I am explaining first part. Here I am explaining first question. See here, factorize 9x square plus 6xy plus y square. 9x square plus 6xy plus y square. We have to factorize this algebraic expression by using suitable identity. They will not give here the sentence clearly, completely. But we should use a suitable algebraic identity to factorize this algebraic expression. Okay, my dear children? Right. See, 9x square plus 6xy plus y square. These are the three terms in the given algebraic expression. If we observe here, first term 9x square can be written as 3x whole square. Isn't it or not, my dear children? Right. First term 9x square can be written as 3x whole square. And come to the last term, y square is there. So y square can be written as y whole square. So this is a square and this is a b square. And in the middle term we can write it 2ab. Here plus is there, so plus 2a means 3x, b means y. If you simplify this middle term, we get 6xy or not? Yes, we are getting the 6xy. So this algebraic expression can be written as 3x whole square plus 2 into 3x into y plus y whole square. Understood this step, my dear children? Right. By comparing this given expression with a square plus 2ab plus b square, immediately you had to bring back to your mind the suitable algebraic identity. Okay, my dear children, see here a square plus 2ab plus b square. We are comparing the given algebraic expression with this expression. Then we get here a is equal to 3x and b is equal to y. Understood this part, my dear children? Right. Therefore, by using the identity a square plus 2ab plus b square is equal to a plus b whole square. This is algebraic identity, first algebraic identity. Then we get 3x whole square plus 2 into 3x into y plus y square can be written as 3x plus y whole square. A means here 3x, b means y. So a plus b whole square. Whole square means 3x plus y into 3x plus y. These are the factors. These are the factors of the given algebraic expression. Understood, my dear children? Right. Now come to the question number 4. Page number 49 in the textbook. Page number 49 in the textbook. Question number 4 or Roman number 4. In this Roman, there are three questions. There are three parts. So here I am explaining third part. Here I am explaining third question in this Roman. You try the remaining two sums. If you have any doubts, ask your doubts and get your doubts clarified. Okay, my dear children? Right. See that third question, third part in this Roman number 4. Expand minus 2x plus 3y plus 2z whole square. We had to expand the expression with the help of a suitable algebraic identity. They will not mention in the question, but by using the suitable identity, we have to expand this expression. Okay, my dear children, right. So let us write the given expression here: minus 2x plus 3y plus 2z whole square. Immediately you have to compare this expression with a suitable algebraic identity. Nobody tell you. Okay, my dear children, by comparing the given expression with a plus b plus c whole square, it is in the form of a plus b plus c whole square, then we get a is equal to minus 2x, that is the first term in this expression. B means the second term. What is the second term here? 3y. And c means third term. What is c here? 2z. So by comparing the given expression with this expression, we get here a, b and c values. Understood this part, my dear children? Right. Then by using the identity a plus b plus c whole square is equal to a square plus b square plus c square plus 2ab plus 2bc plus 2ca. This is the expansion of this algebraic expression. Okay, my dear children. Then we get minus 2x plus 3y plus 2z whole square. I am substituting a, b and c values in this algebraic identity to expand the expression. Okay, my children, a means minus 2x plus b means plus 3y, c means 2z. Understood this top part, my children? Right, is equal to a minus 2x whole square plus b means 3y whole square plus c means 2z whole square plus 2 into a means minus 2x plus b into b means 3y. Understood this term, my dear children? Next, fifth term is 2bc. So plus 2 into b means 3y, c means 2z. Understood this fifth term, my dear children? Right. Now come to the sixth term. 2ca. 2 into c means 2z and a means minus 2x. So we have expanded. We have written all the 6 terms here. Now we have to simplify each and every term separately in the rough work. Okay, my dear children. Understood this step, my dear children? Right. By simplifying each and every term separately in the rough work, we get here first term is minus 2x whole square. If you simplify it in the rough work, we get 4x square. Okay, my dear children, understood this first term? Right. Plus, if you simplify this second term in the rough work, we get 9y square. 3y whole square. We get 9y square. Understood this second term, my dear children? Right. Now come to the third term. 2z whole square. If you simplify this term in the rough work, we get here 4z square. Understood this third term, my dear children? Right. Now come to the fourth term. If you simplify 2 into minus 2, minus 4 into 3, minus 12. So I wrote here minus 12 xy. I simplified here. If you simplify this term, fourth term in the rough work, you get this only, minus 12 xy. Understood this fourth term, my dear children? Right. Now come to the fifth term. 2 into 3 into 2 into 3y plus 2z into z 2z. So 2 3s are 6, 6 2s are 12. So we get here 12 yz. Otherwise we can simplify this term in the rough work also. Then you get plus 12 yz. Understood that fifth term, my children? Right. Now come to the last term. 2 into 2z into minus 2x. We have to simplify. This is sixth term. You can do it in a rough work to simplify this sixth term, or directly 2 2s are 4. 4 into minus 2 minus 8. Finally we get here minus 8 zx. Minus 8 zx. That is the sixth term in the expression. Understood? This is the expansion of this expression. Understood, my dear children? Right. Now come to the question number 5. Question number 5. In this Roman, there are 2 questions. In this Roman, there are 2 parts. Here I am explaining second part. Here I am explaining second question in this Roman. You do the first question in this Roman. Okay, my dear children, you try it. If you have any doubt, ask your doubts and get your doubts clarified. Okay, my dear children, now come to the question number 5, Roman number 5, and the second question. Factorize 2x square plus y square plus 8z square minus 2 root xy plus 4 root 2 yz minus 8xz. Okay, my dear children, here this is a given algebraic expression. If you observe this algebraic expression, there are 6 terms. This is the first term, this is the second, this is third term, this is the fourth, this is fifth, and this is the sixth. Total 6 terms are there. So let us write all these 6 terms according to our convenience. So here this is the given algebraic expression. So here if you observe, this is a square term, this is also square term, this is also square term, and this is negative term, that is a negative term. If you observe these two negative terms, what is the common letter here? X. What is the common letter? X. So we write here first term as minus root 2x whole square. Common letter is x. Whatever the common letter is there in the negative terms, we have to keep sign for that term, that is x term. Here x is a common variable in these two terms. So for the x term we keep minus sign. Understood this point, my dear children? That is why we are writing here minus root 2x whole square. You can write root 2x whole square, that is also 2x square only, minus root 2x whole square also 2x square only. But here in this expression, fourth term and sixth term, in the fourth term and sixth term, if you observe, x is the common letter. It means it gives an idea to keep sign, minus sign for the which term. Here common letter is x, so for x term we keep minus, so this is x term. So that is why we are keeping here minus root 2x whole square. Understood this first term, my dear children? Right, this is important in keeping minus for any term. Okay, my dear children? Right. Second term is written as y whole square. This is simple part, we can write easily. Plus 8z, we can write this term as 2 root z whole square. I wrote third term as 2 root 2 z whole square. Okay, my children, this is a square plus this is b square plus this is c square. We got 3 terms. Now we directly write the remaining 3 terms plus 2ab plus 2bc plus 2ca without seeing these 3 terms. So plus 2, what is a here? Minus root 2x. What is b here? Y. So I wrote here plus 2ab term. Understood this fourth term, my children? Plus I am writing here fifth term plus 2ca plus 2 into c means here y. A means 2bc, b means y, and c means 2 root 2 z. Understood this fifth term, my children? And the last term, sixth term is plus 2ca. So plus 2, c means 2 root 2 z into a means minus root 2 x. I wrote the remaining 3 terms with the help of algebraic identity: a square plus b square plus c square plus 2ab plus 2bc plus 2ca. If you simplify this third term, fourth term, you get this fourth term only. If you simplify this fifth term, automatically you get this term only. If you simplify this sixth term, automatically you get last term, sixth term, minus 8zx. Understood this part, my dear children? Right. Now by comparing the given expression with a square plus b square plus c square plus 2ab plus 2bc plus 2ca, then we get a is equal to minus root 2x, b means y, and c means 2 root 2z. Understood this part, my dear children? Right. Then by using the identity a square plus b square plus c square plus 2ab plus 2bc plus 2ca is equal to a plus b plus c whole square. Here we are using this algebraic identity a square plus b square plus c square plus 2bc plus 2ca plus 2bc is equal to a plus b plus c whole square. We get minus root 2x whole square plus y square plus 2 root 2z whole square plus 2 into minus root 2x into y plus 2 into y into 2 root 2z plus 2 into 2 root 2z into minus root 2x is equal to, here a means minus root 2x plus b means y plus c means 2 root 2z whole square. Understood this step, my dear children? Right. So we wrote the factors. Whole square means minus root 2x plus y plus 2 root 2z into minus root 2x plus y plus 2 root 2z. Understood, my dear children, how to factorize and given algebraic expression by using a suitable identity. Right.